So we're going to dive into this merge case sorted lists. So this is a hard question. It uses singly linked lists and we want to merge three of them together in sorted order. So the problem says you are given an array of k linked lists, which is 1, 2, 3 linked lists. Excuse me. And these are all the lists. Each linked list is sorted in ascending order, meaning 1, 4, and 5. 4 is bigger than 1, 5 is bigger than 4, so on. Merge all the linked lists into one sorted linked lists and return it. Linked list, sorry. So what we want to do, get the input with these three linked lists together and then put them together in sorted order. So 1 will go first, 1 will go second, 2 will go third, and then 3 will go fourth, so on. So if there's an empty list, we'll return an output of empty. If there are no lists in the list, and then if there's an empty list in the list of lists, then we'll return empty. So k is just the number of lists in the array, and then we've got the rest of our constraints. So it was helped a little bit with this one, but what we can do with Python, which I didn't know you could do before, is we can import libraries. So we're going to import a library called heapq. So import heapq. What this does is this will allow us to manage the priority in a priority queue type way, so that every time we get another element in the list, it will manage it such that it will maintain like the smallest list. So we'll go through that. So first we're going to add the first node from each list to the heap. Each entry in the heap is going to be a tuple. So we'll just have the node value, list, index, just to make sure that if there's like a same value, if we have like 1 and 1, it'll have a unique index, so it maintains its uniqueness. And then for the third value in that tuple, we're going to just pass in the node itself, so that we can eventually add it to our output. So let's go to that point, and then we'll move forward after that. So initially, I'm just going to initialize a heap. Oops. And then I'm going to loop through these lists and push the values of those first few. So for I and node in enumeratable lists, so enumerate. Is that how you spell it? Enumerate. Okay. And then I'll pass in lists from up here. We're going to dive in and make sure that if there is a node, then we'll use heapq to push that tuple I was talking about. So pass in heap, and then we're going to pass in that tuple. So node.value, .val, the index and the node itself. So that way, every time we'll go through and pass those nodes in and create that heap. After this, what we'll do is, since we need to traverse the lists, we're going to create a dummy head so where we can start and make that our current. And then we'll jump in that queue, or in that heap, and we'll create a results list. So we'll pop the smallest node from the heap that we built and then attach it to the result, and then push the next node from the same list back to the heap. And then we'll just repeat it until the heap is empty. So we'll go in and do that real quick. So while there's still a heap put together, the value, index, and node is equal to heap q dot heap q dot heap pop. It gets heap pop, and then we'll pass in heap. And then we'll just say current dot next equals node, and then we will pass, or we'll move on to the next part of the list. Oops, I totally didn't even do this part. Like, what is going on? So what we'll do in this is create the dummy head so we can actually traverse these things. Like, what is going on? So dummy equals list node, and 0 just to be at the beginning, and then we'll set current to ours equal to the dummy, so we can traverse that. And then we will do a conditional statement, making sure that the heap dot, or the node, the next node is still there. So node dot next heap q dot heap push. So we're pushing this back to the heap, and the node dot next dot value, the index, and then the node dot next. And then now that current, so right here we're building that current node, or that current list, or the dummy list, I guess you'd say. What we'll do is we'll return dummy.next, and that should return our final list. So let's go ahead and run it. And it looks like it was accepted with flying colors. And then we're going to go and submit it, make sure it passes all the different tests. So it looks like we did pretty well. Let's see if I can analyze complexity. I can't. So the complexity with this is going to be O of n log k, where k is the number of lists in the list of lists. So this is k, and then log n comes from the number of total nodes across the list, and then k is the number of lists. So each node is pushed and popped in the heap once, and typically heap operations are log of k in time complexity. So O of n log k in the end.